Welcome to Machine Builder Talk, the podcast where we dive deep into the world of automation, engineering, and the craft of building machines. Whether you're a seasoned automation pro or just starting your journey, you're in the right place to connect, learn, and get inspired. My name is Colin, and I'm your host, so let's get started. Welcome back to another episode of Machine Builder Talk. Today, I'm thrilled to welcome Thomas Benninger onto the show. Based in Austria, Thomas leads Autolab Next Automation GmbH, offering automation and image processing solutions since 2021. His company specializes in innovative automation technologies and advanced industrial vision and inspection solutions. Thomas, welcome to Machine Builder Talk.
Welcome. Thanks for having me. Really glad to do this here. First time on a podcast, so really looking forward to it.
I feel very privileged to have you as a first-time podcaster. It's going to be fun. Thomas, tell us a little bit about yourself and how you got into the automation industry. What's a little bit of your background?
Yeah, I always worked in a production company during school and later during studies because my dad is from production and has a company there. And then I was like the normal way, a lot of maintenance stuff, like PLC stuff, a lot of S7, Siemens, Tierportal, also some S5s. And yeah, so I was always in that business a little bit. And then after study, I went fully on it, but really with building machines and building programs for it, because it always felt like there is room for some new approaches, because I think naturally when you know like the difficulties from the production side, you see what's good, you see what's bad. And so, yeah, I thought it was a good idea to try something there, and that leads to Autolab, where we try to do a few things a little bit different. And yeah, since until now, I think it worked out quite nice, but it's always a challenge to being the new guy and try to bring some new stuff. But it's fun.
What was the first role? What was your first job in the industry?
Yeah, just existing machines, and then try to optimize them a little bit, digging into bugs. I think a lot of like code from the outside, so not your own code, so it's always a little bit difficult to look for bugs and stuff like that. Then small extensions like making a new station to an existing machines, stuff like that. Yeah, that was the first beginnings. I think still good to have them, because I think it really digging into other stuff really gives you a good practice in how to debug stuff and find also nasty bugs. Naturally, you don't want them, but it's a hard school, I think, and yeah, doesn't hurt to have.
Right. So from the angle I'm looking at, you've really been from the beginning an innovator, looking at ways to improve the machines. And has that been more from the software side or from the hardware side, or a bit of both?
I also have a little bit of experience from the hardware side. Also, mechatronic is quite common in schools. So yeah, but when I looked at the problems, I'm more like the software guy, I would say. And I think even like I remember back then, I didn't even like the PLC side too much sometimes, because it felt like really tight for when you also know the software approaches. I think it changed then years later when I saw, okay, there are systems out there that lets you program in a way that is naturally to you as a software developer. And that really got me thinking that what you can do. But I think I always had this software view on problems. I think you can also, yeah, I think if you know me, you always know that I'm more the software guy in that regard. Yeah, naturally, I think that was the viewpoint more for me than anything else.
Okay, so I'm going to actually ask you your favorite way of programming logic. Okay, so I started off with relay logic into ladder logic. Okay, so that's my comfort spot. What is your favorite flavor of programming? Is it ladder, function blocks? Tell us what you prefer.
I know also the ladder stuff. Did it back in the HTL and school. For us now, we do all in structured text, also logic, because at the end of the day, I think it feels more natural to us. Our team is mostly software developers, and also because we try to use Git extensively. Unfortunately, I think the most PLC tools are in a way that if you go for structured text, it's the most compatible built with the Git-based version control. So I think that also has a big part. But yeah, we just love to work with Git and to work together then. And so in our case, everything is structured text, even logic. Even though, I mean, for some things, I think Lada could be on the first sight more intuitive. I think at the end of the day, for us, the only structured text approach is the right. But I see it for logic, to be honest, but we don't use it. So yeah.
I can see why. I mean, structured text is actually being adopted by more of the younger generation of machine builders and programmers. There's lots of reasons, as you said, to get that you can work on it collaboratively from many different places. You've got your revision control, which is a lot easier to do than ladder
Yeah.
programs that are just basically on one computer most of the time. But what are the key advantages for a structured text program as opposed to that? Um, Structured ladder scan type PLC. Is there any speed performance or performance benefits for structured text over ladder?
I do not think so, at least for backoff, because at the end of the day, it's all compiled to similar machine code. I mean, I'm not a compiler expert, but don't think this adds too much value to differentiate. For sure, it can be that one piece of code is a little bit faster here and there, but don't think there's a tendency. I think for us, it's also like we have a lot of programmers that are just familiar with C++, for example, and so
Right.
just seeing like an if-else statement that really tells us what to do. And if I get the programmer that's maybe not too familiar with PLC, if I give him a structured text piece, he knows what it is, basically, at least for like the basic instructions. I think Lada is just not. It's really nice if you have this electrical background, then it's natural for you. That's
Yeah.
the reason why it came from, and then it's really great. And the people we have, they all have a strong software background. So for
Right.
them, it's the strange thing. So I think it depends so much from which perspective you're coming. Yeah, I think that's the bigger part to it in terms of. I think it's always the discussion online that people say, for example, ladder logic is so much better because it's so intuitive. Yeah, it is if you have this electrical background. I think for
Exactly.
the normal guy who walks on the street, I think an if else, that's literally natural language. So I think it really depends on your perspective so much, and also it's preference. There's no right and wrong. For us, there's a little bit because of the Git approach. There we would have we would have a harder time with Lada, basically in terms of merge conflicts and stuff like that. But
Right.
just for
Well, you're
developing,
you're absolutely right when it comes to the intuitiveness for someone that's used to reading electrical drawings and schematics. Going to ladder makes sense to them. Okay,
yeah,
totally sense.
yeah,
Everything's logical. But if you're coming from a different background, a software background, or even just with no electrical drawing experience, ladder is very confusing. I mean, you have to understand the basic electrical
yeah.
instructions at that point, and where you've got and if or statements from a structured text point of view, that makes more sense to people because they're using those kind of decisions every single day in their normal lives, right?
Yeah, yeah,
So I think as the younger generation, and we're going to get onto this a little bit more because this is how our conversation started, was about the younger people in the industry coming up and trying different things. But before we get there, tell us a little bit more about what your company does, what you specialize in, and kind of what applications you can solve out there in the industry.
yeah. I think our specialty is inspection systems, inspection machines, so all sorts of stuff like electrical inspections, mechanical inspection where we measure the length and stuff like that, and also a lot of machine vision inspection nowadays, because the nice thing with cameras is you don't have to put on a new inspection mask or anything. You just switch the program and then you can use the same machine for a different part type. And I think our specialty is also like inspection machines where we inspect a lot of parts per day or per year, so to say. For example, on our flagship end of line inspection, we test 12 million parking housing sensors a year. And I think this is our specialty. And because our background was always from automotive industry, so really strict quality requirements and really a lot of data tracking you have to do in the machines. So I think that's also why for us, this like PT-based TwinCut approach makes so much sense because we already have directly at the machine so much data to handle, and every part must be traceable. So naturally, you end up really having a lot of data to handle directly on the PLC side, and I think that's why we enjoy TwinCut so much, and also that's why the machine vision side nowadays is quite prominent in our company. There we also do standalone machine vision applications where you just get out our AutoLab PLC and then you just plug in the PLC you want to it. For example, if you use Siemens, we communicate via Profinet to you. If you use TwinCut, we communicate via Ethercad, and then we just make the equation and everything on our AutoLab EPC. And there you can really have the standalone machine vision applications from us. And also, I mean, we talk a lot about software, but in machine vision, it's really important to nail the quality of the image. So therefore, usually a lot of thoughts go into which light do you need, which optics, which
Right.
cameras, how can I make it robust? It's a different thing if it works for 20 parts or for 50,000 a day, like we have in the parking sensor housings. So that's a different challenge. So I think on the machine vision side, really big challenge is the optics of it. So naturally, you have to fiddle around with real life testing beforehand, and also to dig deep into what just makes sense or not in terms of optics and lighting. Yeah, different materials, different to handle, but quite interesting. It's also the part of the job where you get to know a lot of different industries because basically everyone can use some machine vision application.
Right. Yeah, I've got you. Now, you're based whereabouts in Austria, are you, Thomas?
In Graz, in Graz.
Okay, so where geographically do you cover? Are you able to cover most of Central Europe there for applications, or are you just operating within Austria, Germany, that
Yeah,
area?
nowadays it's more like the German speaking stuff we do. We still are a small company. I mean, especially I think the machine vision stuff can scale quite well. So because that's more like a plug and play thing, it's a little bit easier to handle at the end of the day. But for now, Austria and a little bit of Germany is like our region where we operate.
Right, good. Now, what it would be the thing that differentiates you from your competitors? What do you do differently? What value do you provide that separates you from maybe another vision integrator company?
I think on the vision side, what we really try to do is to make it generic. We try to have our own AutoLab EPC where we then deploy our vision app, which works with almost any camera manufacturer. Also, doesn't matter if it's line scan or area camera or even 3D stuff like laser profilers, as long as it provides us some generic protocols like Gen eCam or Gen eVision we can handle with the data. And then you have this really nice generic image acquisition. Then also there you have then the choice either for complex projects where we should make the whole application. We can then really look what does the customer need, how does the product look, what is the problem, and then we can decide okay either we go with the Halcon library and then combine it maybe with some AI network at the end of the pipeline. On the AI side, we can really deploy almost any network. So we are not dependent on, for example, the Connect stuff. So we can really just deploy our networks. And also we can just say for another project, it makes more sense with the TwinCut Vision library or just with OpenCV. So we really try to work with generic interfaces, so generic image acquisition as soon as the manufacturer implements one of these protocols, and then also like generic deployment of the AI. So you could also, for example, use our vision app just for image acquisition, and then you can deploy your own AI afterwards. Because I think, especially when it comes to AI, we also have our training tools, our labeling tools, so you can really label yourself and train the network afterwards if the process changes or something. But you can also, if you have existing companies which already are satisfied with their AI solutions, as for example, if it's deployable as ONNX, we can just deploy it on our Vision app. So we try to keep it flexible. I think that's what you need in industry, be flexible.
Right. Okay. Now, from an AI point of view, as that's starting to become a major part of vision these days, machine learning, are you integrating that level of implementation in vision solutions so that we're actually learning from bad parts as we inspect them?
That we so anomaly detection that you just learn from bad parts, you mean?
So normally with the vision system setup, you teach the vision system, good parts versus
Yeah,
bad parts,
yeah,
and look for parts that have flaws. But sometimes it's impossible to put every single bad part through the
yeah.
vision system prior. Okay, so
I get it.
I'm working with some companies here in Canada where they're introducing machine learning, technology into the vision algorithm so that if there is a bad part detected, okay, we can go back later on and actually identify that image and then mark that as a new bad part.
Yeah.
So it's a learning process so that if that ever comes up again, it will be rejected immediately instead of getting through the vision inspection.
We also do that several approaches to tackle that. First is we have an approach to just learn with good parts and then do some anomaly detection. That's one part because sometimes you don't even have bad parts. The second thing is we always have a big ring buffer where we buffer all the pictures, and then if you want to label it afterwards, it's just like I always say it's like Tinder for parts. So you swipe left or right if it's good or bad. So that's yeah naturally integrated with our apps. And then what we also do if it's really a complex task, for example, one of our first big project was from some rain detection sensors. They have really complex surface, and the errors look like really different every time. And the errors only were at one place in our labeling set, in our first training set. So we then went to classical image acquisition, altered this error and placed this all over the image and on different good parts. So we like manually created virtual images of bad parts, but there is also a way to do that automatically. So rotate it a little bit, that we also do. But if it's really some challenging thing, then we can also in our history really go with classical image techniques to use them to make some artificial bad parts. That's then always a little bit manual work, but there are some tricks to handle that, but that's always the difficult. Most of the time you have a very weak training set at the beginning and it gets better with time. I mean, the great thing nowadays is with the pre-trained networks, usually you have an already good solution with only like 50 images to start.
Right.
And then we can deploy like on day zero of the production, we can deploy some working stuff which is not perfect, and then especially with this machine where we have like 10 or 50,000 pictures a day, it's really fast to learn from them and train them, but it's
Yeah.
always a living process, I would say. AI, that's also why it's so important for the machine owner to have ready and easy labeling and training tools, because
Right.
the least thing that your customer wants is that he or she has to call you every time there's a little flaw.
Right.
It
Yeah.
must be possible to train the networks a little bit, to refine them, because especially like 3 years later, maybe the machine is somewhere else, the lighting is a little bit different, the process also changes with time. For example, I know a lot of molding machines now, but just the molding tool, it gets different with time, so just the surface looks different. It's not a
Right.
bad part, but it looks different. So the customer must have the possibility to easily train them
Well, the
without any expert.
material changes, the
Yeah,
raw material changes, maybe a
exactly.
slight color change or slight texture change that, is beyond their control. Maybe it's
Yeah,
right. So all those, yeah, I think that's a really valuable point there, is to retrain the system based on any slight changes in the part or the material being used in the part for sure. So staying on vision for one more second, I want to
yeah.
know about your most difficult or your most triumphant vision applications, the one that you worked hard to solve and then were really proud of at the end and say, we did this and it
Yeah,
was nearly impossible?
I would say two different kind of projects. Similar difficulty, but different in approach. First, an AI approach where we had to inspect the contour of something, and it's like half a millimeter of contour in a circle, so really, really few pixels. So you already have this 5 megapixel image, but the pixels you inspect are like only a hand of pixels is the
Right.
error then. And so you really have to fiddle around to only get the right spots in the image. And you really have to be so careful with lighting and then also with training the network. So that for sure was one big challenge because, yeah, very few pixels remained for really doing the AI
Right.
control.
Yeah.
And the second one was just a measurement. I think I have it here. Some of these parts, I don't know
Wow.
if you see it, but
That,
they have like really a lot of pins. And we have to measure it in 3D up to a couple of hundreds in accuracy. And this is just, and also like how the planes that the customer defines for measurement are built with a lot of points. So it's really, really accurate measurement every 20 seconds, 24/7. And it comes down to hundreds of accuracy, hundreds of a millimeter. So
yeah.
that's a different challenge. So a laser profiler, and we were able to bring the cost really down by using our Geek A again ECAM vision approach. So that was really, really, really nice. But that's just the sheer number of pins and the accuracy required. Yeah, then you deal with the measurement department, with the quality department, and yeah, it just is always about hundreds of a millimeter. So yeah, different challenge. But also nice, I would say, or yeah, fun project, even though it's difficult, but yeah,
Yeah.
it's not
That,
boring.
that part you're holding up looked like it was a complex part to look
Yeah,
at because A, it's black.
yeah, true.
And right, that's usually first of all, that's a difficult one to start working with from a lighting point of view, and you've
Yeah,
got to get your angle of reflections right and everything with
yeah,
that. But the amount of items to measure on that part there were maybe 100,
yeah, and it
maybe
changes depending on the
yeah,
type. So
right.
on that type, only that pins prevail or remain. So yeah, it's, also you
So
have to build your software in a way that it's still one nice code you can manage and don't have to rebuild everything for every part. And yeah, especially with the lighting, if the profiler hits the pinhead, then you have really strong and bad reflections. But you need a lot of lighting because of the black stuff. So
yeah,
yeah, it's not
exactly.
ideal.
You've got to make it not black, basically,
Yeah,
right?
yeah,
Okay, so let's move on. I want to talk about something that got us connected in the first place. So
yeah,
you posted what turned out to be a little bit of a controversial post
yeah,
on LinkedIn, and it was all around gatekeeping. And basically, the premise, just for anyone that missed that post that Thomas put, Thomas basically talked about how our industry and our people have to change because too much information or too much innovation is being protected by the older generations of people or engineers in our industry. And so, for example, a younger engineer might be working on a project and say, hey, I've got a better way of programming that, or I've got a better way of engineering that particular part of the project. And they get knocked down and say, no, we just don't do it that way. So tell me, A, the inspiration to post that because it was a brave post, and B, what you're hoping to achieve by posting it.
I think the inspiration was like, I think I experienced it myself also. I was always the annoying guy who wanted to try things differently. And also sometimes they worked out, sometimes they didn't work out. But I think the I'm only possible to try it because I do now my own thing with Autolab, because otherwise I would just be stuck with a thing that was always like that. And I think it's quite difficult because in a lot of companies and teams, it's just like, I understand if it's not every idea is good, especially people with less experience, they have naive ideas, so they can be quite bad. But I think often the attitude is, it's not about arguments, it's just like, we don't do it because I have such and such years of experience, you don't, so we don't do it. Without any logical reasoning, it's just like, it is that way, will ever be that way. And I think that pushes out young people naturally, because I think everyone wants to work for something where he or she can, yeah, change a little bit, or just brings his idea on the table. If that's not possible, it's frustrating. And so I think what really happens often in industries, like really gatekeeping, I think also recognizes it under my posts. I know they are sometimes a little bit controversial, but a lot of these arguments is just like, not even from a technical viewpoint, it's just, I have experience, you don't have experience, so
Right.
this is bad and this is right.
So I guess
That's
be,
not so.
playing devil's advocate
Yeah,
here, okay? A lot of time, companies do something a certain way just to maintain standards, maybe from, one machine to the next. It might be a specific way of designing a machine that they've used for many versions, and they don't want to change it because ultimately the end user or their customer will be affected by maybe having to learn new software or new configurations. And, there are reasons there for having those standards or not being willing to change things in the first place. But I think where the angle that you are coming from, and correct me if I'm wrong, is that we should be listening to all the ideas and not just dismissing them because we don't do it that way,
yeah.
right?
And also, I mean, there is a logical reason to not change something, because you have hundreds or thousands of machines running, and you have to keep some standard. But the thing, keeping standard is about keeping a right definition, communication definitions between machines or your IT systems to communicate. Keeping standards is not keeping the software you had 15 years ago 30 years long. That's not a standard, is not the specific software tool. And I think it's possible to maintain standards while still be innovative. I think, for example, what we really like to do is using standards like PackML. Nowadays, I think more and more people start to using it. In some industries, it's just standard nowadays, I think. And I think that's the standard you should look at. Or I think when it comes to machine vision, I think really hardcore standards. If some manufacturers makes his own proprietary protocol, I would never buy that camera. But I think that's where standardization should come. And I think also there you can also learn a little bit from the software and IT guys, because there are some really long-lasting standards where everyone agreed on. And I think in industry that's less common, and then often you're forced to one proprietary system. It's hard to change, so you keep doing what you do for the next 20 years, what you did 20 years ago also.
Uh,
Also, it will work for a medium time, it will work, but I think a lot of companies will have problems in the future because it doesn't attract younger engineers anymore. And the older ones will go to their retirement, to the well-deserved retirement also. And then I think at some point you will face problems with keep doing what you did. You Even if at some point you have to change, unfortunately.
well, yeah, absolutely. I mean, you inspired me to write an article about this, and
No,
I
thanks.
wrote, they think plug and play, designing machines for the next generation of machine builders. And you think about it, most of the machines today, especially from an electrical point of view, are designed for the skilled electricians that were young electricians 20, 30 years ago.
Yeah,
And we really haven't evolved our control panels to where the technology is. Our technology has advanced so much now with a lot of IP67 solutions, for example, where we don't necessarily have to put drives inside a cabinet anymore. We don't even need to put PLCs inside a cabinet
yeah,
anymore. But it's just like, well, that's just the safe way that we just build machines like that.
yeah,
And I think young people are coming with better ideas, and this is how innovation, evolves, basically, this is how it works, is that younger people come into the industry with different backgrounds. And for example, the Gen Z generation that's coming into the industry now, they've never ever existed without the internet. They've
True, yeah.
never existed without a handheld device
True, yeah.
and plug and play, basically taking a cable that they could just plug into the bottom of their device and it charged and it connected them to their computers. That's all they know, plug and play. They didn't have to
Yeah,
install
yeah,
any drivers, right? They
yeah.
haven't had to mess around with serial, settings like parity stop bits and baud rate,
Yeah,
like the
true.
old days of serial. They've never had to really deal with things not working straight away as you plug them in, right?
True, yeah.
And
Yeah.
so, but we're still designing machines built for people. That was the way. We expect them to be complex, and complexity of the machine is at that level where we need to have a highly skilled person, where we don't really need to, because if we design the machine differently, instead of wiring up individual wires to terminal blocks and connecting everything inside a panel, we could be connecting them out on a machine with simple M12 connectors, for example, or M8, whatever style of connector you want. And, someone could start the same day and actually be doing that fully productive by the end of that first day. Now, you can't
True.
get someone building panels on the first day
No,
effectively that
no.
you could trust their work. You'd have to go back and definitely inspect it. So you're a forward thinker in the way that young people are coming into the industry. We should be more open-minded to some of those ideas, not necessarily adopt them all straight away, but at least listen to them, analyze them, look at them and see if, hey, this makes sense. So where do you see our machines going, the machine design going from, let's say, in 5 to 10 years? What do you think the design process is going to look like there? And I'm thinking more digital twins and things like that. So what do you think?
First of all, also regarding your articles, I think you put a great calculation in that where you compare how many hours a skilled person need versus unskilled. And I think
Right.
logically the calculation made sense. So I think also that's the way to go. So the great articles, thanks for that. And I
Thank you.
think that's how it's about. Just like analyze it and see does it make sense or not? Because usually the nice thing about ideas is with like small calculations which take like maybe half an hour if it's long. I can say, is it a bad idea, is it a good idea, is it maybe an idea that could work? So it's quite fast to rule ideas out, but with only a little effort. And I think then when young people are suggesting something, just dig a little bit into it. Maybe it's a good idea. Often it won't be because it's naive, but there are great ideas out there, especially from people outside, because they're not blind to the stuff
Right.
anymore. Yeah, but regarding the new machines, I think also like the electrical side will be way more plug and play. General, the device side has to be in a way that you can just connect them easily. And also, I think a lot of stuff now has these great diagnostic tools. I think that was also mentioned in one of your articles that you can just look for the error instead of digging for the wrong wire or the right wire to find, so to say.
Yeah.
And I think that will be a big part because time to market is really, really fast nowadays. So you cannot afford to make things complicated where you have an easy solution. I think also the digital twin stuff that you mentioned will be important. For now, we only really simulate a lot of stuff for the robot, because if we nail that right away in the simulation, we can really get rid of a lot of commissioning hours. So
Yeah.
robots often is like, yeah, a couple of like 1 or 2 hours to teach the position then in the machine to an accurate position, and then it basically works. So there you
Yeah.
can really get rid of a lot of commissioning hours. And also thanks to some of the back-off stuff, it's also really easy to simulate the XDS and something. So I can simulate the base flow of parts already. So I think we have to do more there also, but I think with digital twins, you can really get rid of a lot of commissioning hours, and they really are costly most of the time. But regarding general the software side also of it, I think it's quite hard to predict. Technique and software nowadays move so fast. It's
Right.
so
Yeah.
difficult to anticipate exponential growth. Yeah, I think a lot of stuff can happen. I think it will be adventurous and a great time. But I think building machines could look radically different in 50 years. And then I think we need the new generation to maybe deal with that, and the more experienced engineers have to guide them to make it in a way that they don't waste time with the naive stuff and rule them out fast, but give them space to develop. But yeah, I think it already nowadays, I think machines that were built 10 years ago were radically different to a machine where you really go for all the newest technologies.
Yeah,
It's really hard to predict.
machines now, even from I studied in the industry 30 years ago, right? So I'm old, but the machines have changed so much from 30 years ago, and then from 30 years before that, obviously it changed even more. I mean, 50 years ago, there was very little automation. It was someone
Yeah,
holding a button down, a run button, and then watching it and then taking the button up.
yeah, yeah,
Thumb or finger off that button when it stopped, right? Got to the right place, okay, index it, or they
yeah.
would do that. We're actually working on a software called Uconnect
Hmm.
that essentially is a kind of virtual reality type software where you can imagine the machine in front of you and you can touch it. You can measure for cable lengths and connection
Nice.
points and stuff like that. So we're a hardware company working on software solutions now for the design. And I think, ePlan of really pushing the design spectrum further than any other company right now. And I think by the time, this decade is finished, I think we're going to be looking at, something like ePlan that's part of a simulation software of a digital twin. So essentially, you can design your whole machine from ePlan, visualize it, and run it without building a single thing, and then
Yeah.
order all the materials that you need to build that machine off of that twin. So you'll know your cable length from one point to another, even if it's got to go up and over and around.
Yeah.
You'll know exactly how long that cable is, and you won't have to buy a single-ended cable and add a field attachable. You can get a double-ended cable. That's from my point of view. But there'll be other major advances in actuators, for example. I think the days of pneumatic actuators are on their way out. I think we're on the
Mm,
decline. I think we're going to see a lot more electrical actuators out there,
yeah.
especially low voltage. 48 volt seems to be a good voltage, and 72 volt. I think we're going to start seeing some of those as well for more high power applications,
Mm,
right? So, and it's an interesting industry. It's always moving. I've never had a day of regret for being in the
yeah.
automation industry. It's never boring, that's for sure. Okay, so you know what? We're starting to crack on here. I'd like to get your perspective on, what would you be doing? All right, so I ask every guest this. If you didn't get into automation, what do you think you would have ended up doing instead?
I think something, maybe a cook or something in a restaurant.
Really?
So yeah, yeah, yeah. I think I would
That
love that to just yeah think of meals that I can make. Me and my wife always joke about if AI takes over and she's also in software and we lose our jobs, then we will open up a restaurant. So that's my exit plan if AI replaces me.
and then automate it because
Then,
restaurant owners work harder than anyone else in this,
I think so too, yeah. But
So
I don't know that. I think I would love it, like running a restaurant.
there's some innovative automation going on in the kitchen, these days. I've seen some
Really?
behind the scenes, yeah, with robots making or being a sous chef, for example, chopping things. So the only thing that does, it takes the chef's apprenticeship away from, they've got to go through that, be the sous chef before they can become the master chef and go through the process. But yeah, there's some really cool robotic stuff going on in the kitchens these days.
What
It will
would
be, it will,
your alternative strategy look like if it would not be automation?
For me, no one's actually asked me,
Really?
what would
Okay.
I yeah, what would I be doing? Yeah, I asked that question to every guest, and I never even thought about my asking myself. I think I would be probably a woodworker because
Ah,
yeah, because when I was younger and at university, I made the decision to go with electronics or woodworking, and it was a
nice,
really hard decision. I ended up going electronics, which got me into the automation industry. But I still like making things of wood, so
nice.
I think that or maybe a photographer, because I also enjoy photography as well and photographing things. So
Sounds also
there's a
great.
guy on YouTube called Thomas Heaton.
Okay.
I love his lifestyle. He goes out into the countryside and takes some beautiful photographs in his camper van. So there's a bit of a kind of outcome to his videos, but I'm sure it's not like that in real life, you know? Anyway, so another question I ask everyone is, what is one tool or one thing you use every single day? Okay. And you can't just say AI because that's just generalizing. You can say a specific AI tool if you want to, but something you use every single day that you would not give up for your life. You can't take that away from me. I can't live without this.
But yeah, I think I would say Git. Git or the Atlassian stack. I'm also,
Okay. Yeah.
yeah, I think,
Okay. That makes sense based on your background
yeah,
and what you're doing. It really is important to you, right? So
yeah.
one of the other things I'd like to find out is, on a personal level, what's your favorite hobby or activity you do outside of work?
I really like sim racing, iRacing, and this kind. It's also a little bit a technical hobby, so I like that the part of it. Also, you need a lot of focus for it, so yeah, sim racing I would say is my
Oh,
favorite hobby.
very cool. All right. And the last question before I find out a little bit more of how people can find you is, what is one piece of advice that you would give to your younger self that you wish that someone had given to you?
I think really focus on good team building, on building the team. I think when you start something, you overestimate the technical difficulties and underestimate the challenge of building a great team and also how much fun it is to do that. But I think that, yeah, that was a little bit of a blind spot. Worked out great anyway, but I think that's what I would say to my younger self when I started it.
That's a really good bit of advice because I think we all get distracted with the technical challenges and overcoming those before
Yeah.
the people challenges. And I think if we have the right people in the first place, the technical challenges are easy. They get taken care of.
Exactly, exactly. And
Right.
it's always a team is so much more capable than every single member of it. And then it, like you said, it becomes easy when it just runs smoothly.
Excellent. And I'm guessing you have that philosophy with your team there
Yeah.
at Next and Autolab. Yeah. So how can anyone find you if they want to find more information about vision and inspection systems, automation system, advanced automation systems in Central Europe, let's just say?
Yeah, naturally, if you follow me on LinkedIn, doesn't hurt. I try to put out all the news from Autolab. Also, our LinkedIn Autolab company site is always a good way to be and look for infos. We also made the website new, so there are more products now that we make. And also a YouTube channel from Autolab is also there now, which is quite nice. Then you see some of the HMI stuff and some of the projects. We try to make more videos of the newer machines, but that's always a little bit of effort. But yeah, I think this would be good ways to be if you are interested in us. Yeah, just and also just reach out to via the office mail or just write me on LinkedIn. I think it can be really low effort on LinkedIn. I'm always happy if someone is interested in our stuff. So yeah, just reach out to me. And I hope I can answer all the questions that you're interested in.
And I'll put all those links in the show notes, but I would highly
Thanks.
recommend following Thomas on LinkedIn. He does post some really good posts and a lot of good information, different ideas and perspectives on there on a regular basis, and definitely worth following on LinkedIn. So, Thomas, thank you for your time today. It's been an absolute pleasure talking to you, learning more about you. I look forward to meeting you at person some point in the near future. And I'm in
That would
Europe.
be
I think
great.
I'm going to be in Germany. I don't know how close I will be to you, but a couple of times this year. So if I do
That would
venture
be
up
nice.
into Austria, then we'll definitely reach out and get together. But it's been a pleasure having you on the show. Really appreciate you giving me some of your valuable time, especially as it's getting into the evening there in Europe right now. So really appreciate you coming on.
Thanks a lot. It was really fun. Thanks for the invitation. I really enjoyed it. Thanks. Great talk, great podcast. Thanks.
And that's a wrap for today's show, so thanks for tuning in to Machine Builder Talk. If you enjoyed today's episode, be sure to click subscribe so you never miss an episode. And if you really like listening, a quick review goes a long way to help more machine builders and automation pros like you find the show. Until next time, stay curious, stay connected, and keep building.